This is Team XF03, and we built a omnidirectional robot with a moving arm. These unique mechanism wheels allow the robot to move in any direction and allow for in-place rotation, which could be useful in tight spaces. The use of Bluetooth and app control allow for a reduced overall cost and to be easily customized based on the intended and required purpose. Applications of this robot include replacing humans in dangerous settings, such as high-level biological containment labs, where human error could lead to leaks of dangerous pathogens, for example, and this has happened in the past. We can also use this in places contaminated with radiation, where there is a need for precise work that is too dangerous for humans. The benefits of this project over similar robots is our low cost. We use 3D printing for most parts of the arm and wood for the body. This brings our overall cost to much lower than the competitors with the same functions.
So this is Yazdan, and my part in this project was to build the arm of the robot mounted on top of the part with the purpose of picking up items. To design the robot's arm after the rough design sketch on paper, I used SolidWorks software to 3D design and assemble the arm. Then by using 3D printer, the design parts for the arm got printed, and then arm consists of 5 joints: waist, elbow, shoulder, wrist, and gripper. And each joint has some degrees of freedom. For example, the waist has only 1 degree of freedom since it can only rotate clockwise or counterclockwise in only one direction. So also the arm consists of 2 types of servo motors, so it can move MG996R servos and SG9 macro servos. I use the MG servos for the movement in waist, elbow, and shoulder of the arm, and I use the SG servo for the movement in wrist and gripper. Both servos operating voltages are at 5 volts. Since the battery operating voltage was at 12 voltages, the power could not directly transform into the servos with 5 voltages. That's why I decided to use buck converter to reduce the amount of voltage from 12 to 5 volts. Both type of servos have 3 pins, in which 2 of the pins are ground and VCC, which is 5 volts. And they both go through the buck converter, and the other pin is allocated to the Arduino board. And by attaching the DuPont jumper wires to these pins, we can make the servos move in different joints of the arm.
My name is Kenneth, and my part of this project consisted of the robot car with the mechanism wheels, which is essentially the body of a robot. This part connects all the work from all the group members, including the arm, communication, and control. We started this build with the electronic parts, and we had them connected on a breadboard with jumper wires. And these right here are the A4988 stepper drivers, and these essentially control the stepper motors. And these right here are the NEMA 17 stepper motors powering the wheels along with the Arduino Mega. This worked fine when we were using the transformer as the source for power, but when we switched to our battery, we were drawing more currents, and the wires we were using are really thin, so they got hot. We improvised and used a CNC shield to make all the connections, and this was originally made for the Arduino Uno, but we made it work for the Mega, and this left us exposed digital pins necessary for the other members of the group to make their connections. And this CNC shield allowed us to connect thicker source wires to prevent overheating, and you could see them right here. For the body design, we went through many different shapes and sizes, and we concluded to not use curved corners like in these ones, and instead we used these straight corners because we were making it out of wood and it would be really hard to cut that round shape. And that was our final model right there. And here is the construction of it from wood. And we used a staple gun to put it together. And here's the final product. Hinges for the back so we could easily access the battery and the vital components. We then painted it for aesthetics and added all the electronics inside. Did some wire management and tested it right here. It was really loud, so we added some rubber spacing between the motors and the body for the resonation. And we finally added the mechanism wheels at the end. Finally, we did some tests to ensure everything was working properly, and we moved it in every direction.
Hi, my name is Jatushin, and I am working on the smartphone app and voice recognition. So I developed the application. Initially, I wrote it on Android Studio, thinking that it was the best platform to develop on. But then we later discovered that MIT App Inventor was much simpler and easier to use, and it would better incorporate into Arduino code. For Androids, switching over to MIT App Inventor, we had a lot of resources to draw on, and the UI and ease of use was much friendlier. So it was easier to develop rough drafts and test them on our phones or other devices. We had many different obstacles in this whole process, but one that stood out the most was our different screens. When we had two separate screens and we would try to connect to Bluetooth, the main screen would connect, but then the secondary screen would not connect to the Bluetooth. It would disconnect every time we switched the screen. So since we couldn't find another solution other than having to pair them on every screen separately, we instead opted to have a single screen device. So we used a tablet and fit everything in one single screen so that we wouldn't have to go through the hassle of connecting over and over again. And then I also helped develop the Arduino code. Every member had a part to play in the Arduino code. My contribution here was writing the methods that was outlined by other members. The other members wrote each component in detail and what it did. I, along with student D. Mahmood, had implemented all the methods.
My name is Mahmoud, and my contribution in this capstone project is wireless communication and control. The primary component used for wireless communication is the HC05 Bluetooth module. HC05 Bluetooth module is a Bluetooth serial port protocol module designed for wireless serial communication setup. It is easy to use in application and can be set as both a master or slave setting, allowing for two different devices to be connected. Using serial communication, it can be connected to other electronics and is compatible with either a joystick controller or a mobile application. Its versatility makes it an incredibly useful component in the design. In the Arduino code, the software.serial library is used for serial communication with the Bluetooth. The primary function utilized is the Bluetooth.available function. It works by constantly checking if there's any upcoming data from the smartphone application. If there is data sent, then the data is read and stored. Once Bluetooth connection is established, the smartphone application will send bit values 0 to 25 based on the buttons clicked on the app. Each bit corresponds with a specific control of the robot core or the arm. For example, if the backward button is clicked on the app, bit 7 is sent through, then the robot will read it and in return move backwards. Voice recognition works in a similar manner. On the MIT App Inventor, we implemented a speech recognition functionality that records speech when a button is clicked on the Android application. Secondly, the smartphone application will send bits of values 0 to 25 corresponding to phrases recorded by the app. For example, if the phrase "go back" is said, bit 7 is sent through, then the robot will read it and in return move backwards. And with that, voice recognition is established in this project.
Go forward. Stop. Turn right. Stop. Go forward. Go forward. Stop. Turn left. Turn left. Stop. Right, forward. left backwards. Stop.
In conclusion, the group was successful in completing all the objectives of the capstone. The omnidirectional robot car works as intended. Yazdan completed his task of creating a 3D printed arm mounted on top of the robot car that responds to commands from the mobile application. Each part of the arm consists of varying degrees of freedom depending on its application. Controlled by the mobile app, the robotic car is able to grab and pick up objects. Kenneth's task was to create a robotic car with mechanism wheels capable of moving in multiple directions. As observed from the demo, the car is able to move left, right, forward, backwards, sideways, and in other various motions, meeting the criteria of this project. Jatushin completed the design and implementation of the Android app capable of voice command feature, and Mahmoud was responsible for the wireless control element. As observed, both the robotic car and the arm respond to the commands of the Android application and is controlled wirelessly with little flaws. In conclusion, all tasks of the capstones have been accomplished and completed successfully.